Hello everyone, this is Teacher Wayne and I'm continuing my card game that I was making earlier, the blackjack one. I've done an introductory video to this and in this video I'm going to show a further development from the game. I'm not going to show a completed product, but I am going to show a semi-working game, a template you could say, but a few things that if I was making the game I would do different. For a start, if I'm playing this as an open game, I wouldn't actually got Cindy, this character, fully working, and me, Dan, working as well. I've got the twist and the stick working and the reset button working. In the last game I showed you I could just reset. If you look here, I'm resetting and each person's being dished out counters. As you notice, I've got a little card counter so I can actually get the value of each player. So let me just get both of them quite low score. So here, me, I've got 12 and Cindy's got 18. If I twist, I get extra cards. I've bust now, I've got 22 and Cindy's stuck with 18. But we both got low, so let's, if I twist, we should both twist. As you can see, she's got 20. I've twisted and got 17. Let's just keep trying it. You can see she chooses not to twist and these two are just dummy characters. So this is in essence what the game is I've set up. Quite simple. Let me go through some of the elements that I've added since I did the introductory video. So the first thing we need to look at is we've got I have an array that we set up in first cards where we're dishing out cards to each player, and that represents a number that links to the actual sprite in this deck called cards. We have 52 sub images in here, and basically all this AI player number random deck, this random deck basically stores a number between 0 and 51, which represents the 52 sub images, which represents a card, and basically we are dishing them out, the first 8 cards from this random deck to the players, which is what you can see. If you notice here, I've actually added an extra element called AI cards dealt. If you notice, it says 1. We know they've got 2 characters. The reason I've put 1 and not 2, which you think logically it would be 2, but you've got to remember that we're actually including 0, and if you have a 0 and 1, that's 2. We're actually including 0 as a number here, and that's the way I've set it up. So it's actually, in some ways it's a bit hard to get your head around that, and for troubleshooting it was a struggle for me until I figured that out myself. So anyway, let me just show you this translation. I've got this function I created called value of cards. It's one of the core things that I set up. So let me just move this over here, and I'll explain as I go along. So here we are, we have what's known as a function. We have 2 values at the top. We have a card val, and this is what we return to the calling function. I'll go through that in a minute. And then we have an input, which is argument 0, which gets stored as a variable called input val. And this switch, then we have a switch case, and a switch case statement is basically a glorified if then else. As you can see, I've started to comment it here. So basically, if we have a value of 0 coming in, I know that's going to be ace of clubs, so I know that it's going to be an ace, and I know there are 4 aces in the deck, and we have an ace at location 0, we have one at 13, one at 26, one at 39. So I'll show you that. We have one at 13, there's 13, we have one at 26 there, and we have a final one at 39. They are, so those there represent the 3 aces, and then we've got the same for 2, for 1, for 2s. If I just go back here and just show you quickly. So we have a value of when it's 1, subimage 1, we know that it's a 2 and there's one at 14, 27 and 40. If you notice, it's just basically you just add 13. There are 4 2s, there are 4 3s, there are 4 4s, 4 5s, 4 6s, 4 7s, 4 8s, 4 9s, and then when we get to the others, we have different values, because you can have a 10, a jack, a queen and a king. They all have the value of 10, so that's why we have this massive case statement at the end here, because all these can be set to 10, and the aces I've set to 11 initially. Remember, aces can be 11 or 1, but I do have a function that can actually deal with that later, which I'll talk to in a minute. So that is the function called value of cards. You need to do that first, really, and that's where I have. So let me talk. I've got 2 main objects that's working: Cindy, which represents the AI players, and Dan, which represents the player. Let's look at Cindy first. So this is a new element called the step. We had the draw before. Let's open up step. Oh, hang on. Before I do that, let me talk about the twist and stick, because I need to talk about that for a minute. So if we twist, basically, bit of code runs if you press the left, and this is what happens. It just basically says, are we sticking? False, no. Then we set it to true, because that means we've clicked sticking. Then we'd have a little loop, and we have this player go variable. It's a global variable. We set it to true, and I just put a debug message out to this display down here just to say that the sticking is done. This is not properly written or fully written, because what it really should do is sticking should be false, and then we've got to make sure that we can't stick and simultaneously twist. But I've not bothered with that for this demo I've done. And it's very similar if you look at twist. Same sort of setup. We just set the variable to true. We set all these player goals to true. I just want to show you the setup script. In the setup script, they're all set to naught. And we're dealing out 8 cards, and the player's not busted, and the twisting and sticking is set to false as well. So there's a few changes there from the original script. So that's your twisting and sticking. So let's open up Cindy now. If we go to the step event, here we are. So first thing it checks is, has that player had a go? Has she taken her turn? If it's true, then that means you can have a go. If it's false, that means that twist or stick has not been pressed. This is how we can set who's doing it. Obviously player goal 0 is Cindy, but there's player goal 1 and 2, which represents the other players. Player goal 3 is actually the player, human player, who's number 4. Remember, 0 we consider it as number 1. It'd be hard to get your head around. So I've commented this, and I'll let you look at it for a moment, but let me just go through it all with you. If I could zoom in, but I can't. So what I'll do is I'll just talk about it. I was going to try to zoom in there. Sorry about that. That's it. Right, okay. So if it's true, then we can have a go. Then she's got a choice of twisting or sticking. This is all debug stuff, so ignore that. So if my debug is this really simple. If she has cards that are less than the card value, total card value of her cards is 15 or less, then she twists. If not, she sticks. Now obviously, if you're thinking about probability, you might just want it that black and white. You want to do there's going to be a greater chance. The lower the number she has, the greater chance, and the higher the number they have, she less chance. And that can be replaced with quite a complex little function there, and if I get an opportunity I might create another video show that, but not for now. So basically, so she's going to twist as she's got 15 or less. So what do? Well, we increase first of all the number of cards that player has, which is, we use that increments the value. We increase the deck counter, the deck pointer. Remember there's 8, so that goes to 9 now, and then we give them a card, which is what this is. That gives them a card from the random deck. And then we just put a little debug message to say, oh, there she is, she's taken a card, and then we set it to false to say she's had a go, so it stops her repeatedly taking the cards. If we do a stick, nothing happens apart from we set player goes to false. Really simple little step. And the player character, by the way, Stan, if we open his up, virtually identical, except we've got different variables. We've got player cards and player card dealt. we've got slightly different variables here, but we are number 3. Remember, that's the 4th player is us. So let's go back to Cindy again. Now the draw, this is the complicated bit really for the entire game. So let me explain this. Scroll this up, fill it up the screen a bit, and go through all this. Let's leave it that for a minute, because you'll probably want to pause this when you're doing your videos and use this code, and I'm quite happy about you doing that. So let me just go through this. I've got 2 sections. I've got a section up here. This section up here talks about if Cindy's taken a card or 2, I want to do something else, we want to do something else. Now in the previous video all I had was this. That was a simple display. So we display the 2 cards, the 2 cards that this player's got, and then we do, well, I've got this extra value. It just adds the value of the cards. Remember, I created a function called value of cards I've talked about. It passes in the number and the value that is returned. Remember, there's a return at the end of this, is the value of the cards. Card val is returned, and that is what is there. It actually calls it. It's quite a pretty little function, that. So we have the 2 values of the cards added together to give us a card value. And then we draw both of them out. I'll go through this in a later, what this business is here. Let me go through here. So if we have got more than 1 card, in other words 2, remember, because we're including noughts, it's 0 and 1 is 2. So that means we're on our 3rd card. Then we actually want to display 3 cards, don't we? So I've got a little function here that displays it. So it goes round 3 times. That's at 0, and then it goes 1, and then it goes 2. That's 3 cards. And basically we've got this little formula here for displaying where it is on the board, because Cindy's over to the left here, and the cards start from the top and go down. So that's why we've got this little function here. And then we just draw the sprite where it is, and then we add a little variable here increasing the value of the cards, because there's 1, 2, 3 cards and they all add up together. I've got a couple of debug messages that I commented out as well. Anything in green is a comment. If you're doing your own code, I suggest you put comments in. It helps you debug it. And also I'll use these debug messages like I have to try to figure out why things don't work, because that's the only way to troubleshoot games like this. So anyway, as I said before, aces can be a value 1, or they can be a value of 11. When do we want to consider how that works? Well, if we have got more than 21 and we have an ace, the ace automatically goes to the lower value. So that's what this does here. If the card value is greater than 21 and we have an ace, I've got a section here called we have an ace, and it just checks to see if these 11s, can you see here value of card is 11, if I use the card 11 value, it basically is looking for aces, and it sets this variable called we have an ace, and I've set it at false at the top, so it's constantly being false apart from at the end of this function. And then we just simply take 10 off. So where you had 30 before, we have this check, then we now have 20, because that takes into account it, and then it just simply displays this new card value at the bottom. And that, in essence, is what is happening. Really simple. Dan, I'm not going to show you Dan, but it is virtually identical to that. So we've got here twisting, so now we've got Dan's got 20, and Cindy has now got 21, so she's won that hand. Reset. 13 versus 18. If I click stick, she makes a decision to twist automatically, look, and she gets now 19. She's got 21 there already, no point even playing. We both twist 10. I wonder if you'll twist again. It doesn't work. I've got to twist once. I'm going to look at the code for that. So anyway, that is my game reviewed, and I will say good night to you, and good night everyone. This is Teacher Wayne. Thank you.